So in this problem, we're determining how much heat we need to add to dry ice to create CO2 gas. Dry ice is the solid form of carbon dioxide. And you can see the temperature, which is frozen as negative 78.5 degrees Celsius, which makes it essentially very cold to what we're used to. This is why it's often used to help in freezing process. Sometimes if you buy things online and they ship it to you and it needs to remain cold the entire time, a lot of times there's dry ice involved. You can go to Kroger or Tom Thumb or stores like that, and they actually sell it. At the Kroger by school, it's actually by the self-service registers. It's also, the one thing to note is that it sublimates, and sublimation is the process of going from solid to gas without going to the liquid state. And this is very common for dry ice. That's why they use it. It's used oftentimes at Halloween for creating that cool foggy effect coming out of certain decorations and so forth. But that's just the chemistry behind the dry ice. Let's talk about how much heat is needed to change this dry ice solid to CO2 gas. So again, this is one of those questions where I like to do just a little diagram. Right? So I create my little timeline. But we're going to start at the melting point, which is down here at 78.5 degrees Celsius. And we're going to bring it all the way up to room temperature, which according to the document here is 27 degrees Celsius. But you have to remember, at this point, we have a phase change, right? So the first thing we have to do is that QML to do the phase change. And then here, we're going to have our change in temperature. So really, we have to find two heats to calculate how much heat was added. So for the first part, we're going to do Q equals ML, all right? And we're going to call it subscript S for sublimation. And they give you the sublimation latent heat in the problem. It's 571 kilojoules per Kelvin. And then they also give you the specific heat of carbon dioxide gas as well. So if we're going to calculate, sorry for the pop-ups here. So we're going to calculate the heat added to sublimate. Again, this involves no temperature change. This just involves the mass of what we have times that latent heat. So it tells us we have 5 kilogram substance, and it's a latent heat of sublimation of 571 kilojoules per kilogram, which gives us a heat added of 2,855 kilojoules. Again, note the units for the latent heat. It was kilojoules per kilogram. Okay, you can convert this to joules if you want, just by multiplying by 1,000. So that is our first heat. The second heat is now the temperature change. Right, so we're going to use our MCAT formula, and we're going to go from negative 78.5 to 27 degrees. So 5 kilograms times the specific heat of carbon dioxide, which is 0.79, times the temperature change, which was 27 degrees minus negative 78.5. And again, you don't have to convert to Kelvin because this is not an absolute temperature. This is a temperature change. So you don't have to convert the 27 or the negative 78.5. You can if you want, but you don't have to. So this tells us that this is 401 kilojoules. And now the last step is just to find the total heat. So we're just going to add the 2,855 plus the 401, and that's going to give us 3,256 kilojoules. You can go through the process of converting to the different units. So this would be 3,256,000 joules, which then also translates to be 777,830 calories. Right? You can even convert this to kilocalories, so like how much food calorie it would be. So that would end up being 7.830 kilocalories, which remember, this is our food calories, so that capital C calories, okay, which you read in the back of the packaging. So again, these are all correct answers. You just need to see what Quest asks you for. It may ask you for joules, it may ask you for kilojoules, it may ask you for calories. So just remember to use whatever units that Quest or homework or quiz is asking you to find.